Hello, good morning to the first session of March for the DBA Fundamentals virtual chapter. My name is Steve Cantrell, along with Shane O'Neill, and today we have Tim Radney from SQL Skills with common SQL Server mistakes. I'm going to take care of a few housekeeping things first. Okay. Our sponsor, Century One, provides all of the resources that allows us to bring these sessions to you. So, and prize money and other prizes. So please give them a try out. Go to their website. There's tons of free articles, videos, downloads. Plan Explorer is fantastic for troubleshooting. It's free. This is the professional version. Give it a try. You can send in and ask questions about SQL performance on your system, and if you're using Plan Explorer, you can send in specific queries that look really bad, and they'll give you, and it'll randomize and it will mask production data, so you can actually send stuff in and let people look at it, and they'll give you suggestions. So anyway, it's a great opportunity. Make use of that when you can. We're speaking of prizes and giveaways. Through the first half of the year, we're giving away $1,800, which is everything that we had. Instead of giving it out per session, we're doing it in 3 things because it's easier with us with all the sessions that we give to divide it up that way. If you are a member of PASS, you're eligible. If you follow us on Twitter, you're eligible. And if you subscribe to our YouTube account, dbafundtube.org, you're eligible. And then you get 1 entry for each session attended through June the 30th. And first prize will be a $1,000 Amazon gift card, second, $500, and third, $300. Here's some of our sessions coming up. Next week, we'll have Brent Ozar with what to do when SQL Server is slow. Then we've got Paul Randall, Thomas LeBlanc with execution plans, Kendra Little with index design patterns for beginners, then Jess Borland. Let me back up. And Tim just said that he may have a session that we can present for him in June or July. So PASS has multiple virtual groups, multiple languages, multiple topics and sessions. So give that a shot and go check it out. Here's some of the sessions that others are giving. The Women in Technology virtual group is giving a session a week this month. So go over to their site and check that out. They've got one today, right after us. And let's see, we've got 2 more actually. We've got a session down under, and then we've got the one with Brent, and then the Women in Technology chapter is giving another session with Kaylin Delaney. SQL Saturday Night SQL's always got some good sessions going, and then there's Women in Technology again. Anyway, SQL Saturdays, if you've never been to a SQL Saturday, you need to give that a shot too. You can go to SQLSaturday.com and see what the closest one is to you. They're like mini PASS summits, free education. You go listen. Vendors pretty well sponsor and pay for everything. You pay for your own lunch, and other than that, you just have a day of learning and networking. It's a great opportunity, so try that out. Here's some of the sessions coming up. We will be recording this session. It'll be available at dbafundtube.org or dbafund.org, usually with 1 to 2 days. I'm going to turn the session over to Tim. Just a second here. Let me make Tim the presenter. Should be coming your way, Tim.
All right, I just shared, so you should be seeing the intro slide.
Looks good to me.
All right, so we'll get started. This is the Common SQL Server Mistakes and How to Avoid Them session. This session kind of came to be from one of my first ever blog posts on inheriting a neglected database. And it kind of became a session and has evolved over time. In the beginning, I thought that, hey, maybe it was just the company I was working at that, we didn't do a lot of things that I came to learn as a DBA and being involved in the past community and reading blog posts and things and kind of learning and growing as a DBA. I thought, hey, it's probably just us. And then once I started consulting, I realized, hey, these are extremely common. So I started kind of expanding my list, and that's what you're going to get to see today. Is most are a lot of the things that I just find clients not doing just because it's things that you're not prompted to fix, and if you don't know about it, then you just don't know about it. So we're trying to spread the word. So we'll get started. So I am with SQL Skills. I get to work with some really awesome people like Paul Randall, Kimberly Tripp, Glenn Berry, Aaron Stellato, and Jonathan Cahias. We do a lot of instructor-led training known as our immersion events. Those are where you come on site somewhere. A lot of training online at Pluralsight. Everything from consulting, remote DBA, we speak at various conferences, and you can subscribe to our newsletter. It's not a marketing spammy kind of newsletter. It actually contains insider videos and a lot of quick how-tos. I mentioned the in-person training classes. For 2018, we'll be in Chicago, Bellevue, and London. I'm really excited to get to go out to London and teach about Azure. You see our list of training classes that we offer. You can find out more at SQLskills.com training and our consulting aspects as well. Speaking of conferences, this is a past session. I wanted to let you know there is a conference coming up at the end of this month in Disney World. We'll be at the Walt Disney World Swan Resort. This is the SQL Intersection Conference. We have a lot of workshops, a lot of general sessions. It is a very fun conference. So if you're in the market to attend some training in the next couple of weeks, come see us down at SQL Intersection in Orlando. For Pluralsight, if you email Paul at SQLskills.com, put in the subject line user group Pluralsight code, he'll send you a code good for 30 days of all SQL Skills content. We have like 60 courses out there, over 175 hours of content, so you can definitely get your learn on at Pluralsight. My vanity slide, the takeaways here are my email address, blogs, and can you mute? Picking a lot of feedback. All right, so takeaways here, blogs, email addresses, and Twitter. If you have any questions or you want to connect, feel free to reach out either through Twitter, LinkedIn, any of those social medias. So today, what am I going to be covering? Well, foremost, the most important thing to me is backups. If you don't have a proper recovery strategy planned and have backups to meet that recovery plan, when that oops situation occurs, then you're in really bad shape. So we're going to cover that. We're going to talk about consistency checks, log cleanups, statistics, index maintenance, your memory settings, max degree of parallelism and cost threshold for parallelism. We'll talk about Temp DB, some free monitoring with SQL Server alerts, and lastly, power savings. So with backups, why is this important? Well, if you have one of those oops situations and you need to be able to recover data, if you can't recover that data, we refer to that as a CLM, a career limiting move. And being in the consulting space, it's very kind of unfortunate and sad that part of our role is people reach out to us after a disaster has happened asking, can we help? And in many situations, if they do not have proper backups that they can recover from, and they're past a point of recovery, then the answer is in many times no. I mean, your database has become corrupt, it's unreadable, you don't have proper backups, that was the only copy of your data. There's nothing more we can really do. And there are Hail Marys, but for the most part, you're just in bad shape. So we preach you've got to have backups that enable you to meet your service level agreements for recovery. So you need to plan a restore strategy to meet your service level agreements. And so what are service level agreements? Your recovery point objective, meaning how recent do you need to be able to restore to, and your recovery time objective, basically how long can you be down? So how much data can you afford to lose, and how long can you be down? If you ask your business units those questions, they're likely to say no data loss and no downtime, which is almost impossible to reach. But in the real world, I mean, for full disaster, your data centers become a smoking hole in the ground. You're looking at 4 hours up to a day. And the data loss, 5 minutes, 10, 15, I mean, somewhere around in that range, pretty well a standard. And so your transaction log level backups during that time, it is pretty easy to meet those service level agreements, but you have to establish those. Don't just assume them when you take over a system. Validate, trust but verify of what settings are in place today are actually and truly needed. I like to share a story where there was a system I inherited. It had over 4,000 production databases, and it was deemed as a tier 1 system, meaning we had 4-hour recovery time objective and 15 minutes recovery point objective for 4,000 databases. I met with the business unit and just asked a few questions. And those questions were pretty simple. If this system were to die, it goes away, how long before we're taking financial loss or it's a major impact to the organization? It's like 3 days. Wow, 3 days, and we have a 4-hour SLA. All right, another question. If I were to lose your data, database becomes unavailable at 12 noon, and I can only restore you back to midnight last night, what does that do to your department? Oh, nothing. We'll just reprocess the work that we did. We do that by ingesting files. So, okay, so you really don't even need log backup every 15 minutes. I could do differentials every 4 hours and you would be ecstatic. And yes, so able to go and change the recovery strategy for this database, and then come to find out of those 4,000 databases, only about 40 of them were actual read-write. The rest were archived copies where it was like monthly snapshots of this data. So those I could switch to simple recovery. Whereas in the beginning, everything was full recovery. So again, that's a wonderful edge case example, but I have hundreds of examples very similar where databases are in improper recovery models. Like I find a mission critical production OLTP database that's in simple that needed to be in full. So you want to make sure you have proper recovery models and that you're getting the proper level backups for those databases that can meet your recovery strategy. Paul has a great example where it was a solid backup strategy, but when they tried to recover, it took like 4 days to recover a database, and that business didn't survive an outage. So make sure that your recovery strategy meets those service level agreements. And then the other thing is validating that your backups are good. The time to figure out that your backups are bad or that you can't recover from them is not during a production outage where you're dependent upon them. So you need to regularly test your backups. And if you're in a regulated industry like finance, security, or like security and exchange, insurance, anything that has heavy regulation, auditors and examiners love to see your restore validation process. And it's very simple to spin up a virtual machine, throw in a little bit of logic, and have a system that's regularly going through and restoring your databases from their production backup locations. When you're doing that, you can build reports from MSDB on the restore process, how long it took, whether it was successful. You can even build in some queries to go through and validate that the data is actually there and consistent. You can run check DBs against them. I mean, a lot of benefits having this restore validation process, but one of the main things is our databases grow over time. So even though you may be able to meet your SLA for how quickly you can restore the database, as time progresses, that database grows, what happens to your restore times? They're going to grow too. So by being able to tell and validate the length of time it takes to restore a database in an automated process against maybe a configuration table of what the SLAs are, you can start seeing where you're getting close to that service level agreement, where you may not be able to meet it if something were to happen. But the biggest benefit of backup validation is knowing your backups are good, knowing that when you go to sleep at night, if something were to go bump in the night and you have to restore, you know what you're doing. You're not having to go and do a Google Bing search to figure out how, what the restore statement is to recover a differential, and logs throughout that day. You know what you're doing. You just execute your plan. And I have a script that's available, timradney.com/backups. This script brings back the database name, recovery model, when the last full was done, the last differential if you have them, and your last 2 transaction logs. So I like this because I can look at that script and be able to quickly gather whether you have databases in full recovery with no log backups, what your log interval is. So if I'm looking at logs and they're every 4 hours, I know you have a 4-hour potential data loss. I can tell whether you're doing differentials or, it's a good script. It's a great starting point to look and see what your backups are, what your intervals are. And you can modify that script to include backup paths and different things if you want. And on my blog post, people have posted variations of the script that they took the core and added to it to make it work for them, for their need. But for me, the script as is provides the data I need when I'm doing some consulting. So have fun with it. And I hope that your backups are all in great shape. The next thing is consistency checks. So this is kind of the last gloom and doom slide. And consistency checks, what we're doing, or what this is for, is checking for corruption. And 99.98% of the time that corruption is or occurs is due to an IO subsystem problem. That means less than 1% or 0.01% is local hardware or a SQL Server bug. I haven't seen, I want to say it was maybe 2012 that had a bug in an AG that could potentially corrupt, and that was quickly fixed. And that's been the last time I'm really aware of a situation within SQL Server itself that could lead to corruption. Again, over 99% is some IO subsystem problem. And so that means it's not really a matter of if corruption is going to occur, it's a matter of when it's going to occur in your system. So we need to be checking for corruption on a regular basis instead of waiting for a user to hit the corrupt portion of the database and it generate an error, because it could take days, weeks, or even years, depending on where that data is, before it may be accessed and generate an error. So running DBCC check DB on a regular basis, how often should you be running it? Well, that depends. How much data can you afford to lose? I like to see it no less than once a week. I have some clients, their databases are small, their IO systems are fast, they run check DB on a daily basis. Some can argue that that's overkill, but on a weekly basis. But the main thing is that you're running it regularly enough that when corruption occurs, that you have proper backup retention, that you can go back prior to the corruption and be able to get your data back. So running CheckDB, you can also check just your allocation tables. You can run CheckDB against just the catalog, individual file groups. That's fantastic. If you have large partition databases, you can run CheckDB against your read-write. So when corruption occurs, kind of what's the step? Well, many times you have to restore from backup, depending on the level of corruption. And if you get lucky, it's corruption in a non-clustered index. You can drop and recreate the index. You can run CheckDB with repair rebuild. What you really don't want to see is the recommendation to run CheckDB repair allow data loss, because that means exactly what it says. It's going to attempt to correct the error in the database by deleting the range of data that's corrupt. So when that happens, you will have data loss. So depending on where that was, if it was your heap or your clustered index, well, that's your actual data. So that's bad news. So takeaway here, make sure that you're running CheckDB. It is IO intensive, so you want to run it during maintenance windows. Organizations that have large numbers of databases, large numbers of instances. When you go to run check DB, if you try to standardize your SQL Server installs and your scripts and your jobs, be cognizant of if your default job is to run check DB at 2 a.m. and you run that script on every production database, you're going to run check DB on all databases starting at 2 a.m. That's kind of unkind to your storage admins. So do try to stagger on your systems when this runs so that you're not melting your storage arrays. All right, next slide. Purging logs. So this one's fun. MSDB stores all your backup and restore history. And what I find is if people are not running like the Ola Halloran maintenance process or third-party tools that take into account your backup history in MSDB, if they've rolled their own solution, they're not really aware that they need to be running sp_delete_ backup history. And MSDB just continues to grow and grow and grow. And they have all the metadata related to backups from the backup media set, where it went, how long it took, whether compression was used, all of those bits of data, and they have it for the life of the server. And that causes MSDB to bloat, and there's really no benefit there. Now, some organizations do query MSDB for reporting on backups when they took place and so forth. But again, 30 days worth of history, 90 days worth of history is pretty sufficient. You're running those reports, archive those reports somewhere else, and make sure that you're pruning MSDB backup history. Very simple. You can throw this in a SQL agent job where you can declare a date parameter, set that parameter to get date -90, pass that parameter to the sp_delete_ backup history stored procedure, and let it run on a daily basis, and it will keep things clean. Now, there are a lot of other places within MSDB that can bloat, from sysmail, dbmail, service broker. I mean, there's a lot of things out there. I have a SQL performance article that goes into details about pruning MSDB, and the community came out in force, and people posting additional areas that I didn't cover in the post to say, oh, well, this one got me on this, and your log shipping history. I mean, lots of things utilize MSDB. So that article is pretty consistent now with all the areas that you can check, but backup history is the most common that I come across. Also, the SQL Server log. So by default, your SQL Server error log only rolls over at a service restart. Now, I have some systems that I manage that SQL Server service has not been restarted in a year, year and a half. I think that's remarkable that a Windows server has been up for that long. They tend to need to be patched on a regular basis, so that's a different conversation I have with that client. But again, the server's been up for a long time. That means that log, if it's not being manually reset or rolled over, is going to have a year and a half worth of history in it. So when you go to try to look at the log, it has to read that flat file, and it takes a long time to go through and read that entire file and then load it so that I can look at it. Well, if it has a lot of noise in it, I want to apply a filter, and I want to filter based upon an error or something within some keyword. So I have to apply that filter and then wait for it to sort and go through that entire flat file. And that can take a long time. So kind of a better thing to do is to manually cycle that error log by having a SQL agent job. You execute sp_cycle_error log, starts a new log. Have it run at midnight. So every day you get a brand new log. It's not invasive to the system. It's almost a non-event. The kind of takeaway here or thing to consider is by default, you have 6 rollover logs in your active logs, so you have 7 files. Well, if you're resetting this on a daily basis, you now have 6 plus that day of logs, and that's really not enough history to go back. So you want to go into the properties of the SQL Server error log and change that to some other number. So increase from 6 to another number, goes up to 99. 30, 35 is a good number. So if you set 35 and your server reboots a couple of times because somebody's trying to troubleshoot something and they're just restarting the service over and over, then you still got close to 30 days worth of history to go back, and you're really not going to find that you're wanting to go back more than 30 days to log that often. If you are, that's something that you probably need to be using some log analytics. There's an Azure service for that. There's LogLogic, Sumo Logic, Splunk, other systems that could be slurping up those those logs and storing them in another system. Or you can go all the way out to 99. So at least 30 days for troubleshooting is kind of the standard. All right, now let's start talking about some performance-related things. Statistics. I find that unless the customer or the client is very active in the SQL Server community or following blog posts, checking out Pluralsight, the continuing education. Many of the clients I work with, they're accidental DBAs at best, developers that also are responsible for the instance, or could be DBAs that haven't gotten into more. I still have to stick with most are like database developer or application developer, sysengineer types that I tend to work with. So they don't know about statistics, or they've read statistics but don't understand that the update statistics really isn't the best mechanism out there for keeping your statistics up to date. And the reason being is that by default, it's 20% plus 500 rows of data have changed. All data sets that are somewhat active, maybe that works, but when I'm in front of an audience and I ask the audience, how many of you have a table with more than 1 million rows? Of course, every hand goes up. Okay, next question, out of that 1 million rows, how many systems is that 1 million rows 5 years of data or more? And again, every hand goes up. So we say, all right, well, you have 1 million rows and it's 5 years worth of data. So 200,000 rows is a year worth of data. So that's 20%. So a full year of data has to be modified plus 500 rows before statistics would be updated. I mean, that's kind of crass to example, but it's kind of reality. So I don't want to be making decisions today on fact or data that I only had from a year ago. I mean, things change, trends change, styles change. So I want my statistics to be as up to date as possible so that the query optimizer can make the best decision possible for generating the execution plan. So we need a process to update these statistics manually. Now, if you're rebuilding all your indexes every single day, well, index rebuilds are going to update statistics. Index reorganizations are not. So if you're rebuilding all your indexes on a weekly basis, okay, that's overkill for index rebuilds. I see that with database maintenance plans. Rebuild every index, whether it needs it or not, on Sunday. Well, that's also updating statistics, so cool side benefit. Those who are doing index maintenance based upon fragmentation levels, doing more reorgs than rebuilds, well, this is very crucial because the reorganizations don't update statistics. So you need a process in place. So you can roll your own using sp_update stats and telling it your sample rates or full scan or however you want to do that. Ola Hallegren, his index optimized procedure, also includes some parameters for updating statistics. So that's what I recommend for my clients. It works very well. And again, the benefit and the reason very important is your optimizer uses the statistics to build the execution plan. Out-of-date stats means that the query optimizer is likely not going to make the best decision with generating the execution plan, so it's not going to be the best good enough plan. It could be one that's not using a particular index, it could be a bad sample rate, and you get some erratic behavior, high CPU, table scans. So up-to-date stats, very, very important and very simple to fix. I mean, I've had a number of clients that when they reach out, and I go through and do our normal audit and I report back that they're not doing proper index maintenance, and they run the index optimized procedure, take care of fragmentation and update statistics, that I get an email the next day saying that they received overwhelming response from their users wanting to know what they did to the system, what upgrade they put in place, because the screens are just lightning fast between their application. I mean, a orders of magnitude improvement of their system with a very simple change of updating statistics and taking care of fragmentation. So it's a real thing. So mention statistics. So excuse me, fragmentation. So what causes fragmentation within the database? simple things like inserts, updates, deletes. Hopefully you have a lot of that going on, meaning that your databases are busy, that your businesses are out making money, selling more widgets and various things, and that business is good. So it's normal wear and tear, a kind of friction within a database. So the normal Microsoft back in the SQL Server 2000 days put out a white paper. They really wanted to understand what the impact of fragmentation was to the performance of a system. And what they found was anywhere from 13 to 460% based on the size of the environment and the level of fragmentation. Now that's kind of big. And given, I mean, this was in the SQL Server 2000 days on spinning disk, but 460%, and even that low number, 13%. 13% seems like a number compared to 460%. But let's put 13% in perspective. Would you like a 13% raise? Why, yes, that would be phenomenal raise to receive, right? So what about a 13% improvement in performance of a system? I mean, I know of companies that have spent millions of dollars to gain single-digit performance improvements on network, storage latencies, various things, and you can get 13% up to 460% just taking care of fragmentation. So fragmentation in a database, what are some negative impacts of this? Well, one, your data is kind of not as logically ordered as possible, but the biggest thing is that wasted space within the pages that is also read into the buffer pool. So a lot of wasted space in the buffer pool, which is memory. We tend to have a whole lot more storage than we have memory. And that memory, if it's being wasted, I mean, that's less data we can store in the buffer pool. That means we're going back to those, to the hard drives, to the disk, to read data more frequently than we really would have to. So there's multiple benefits of trying to eliminate the fragmentation. And how do we do it? I mean, we talked about the statistics with SP_update stats. With fragmentation, we control it by rebuilding, reorganizing, or you can disable and rebuild an index. You can schedule rebuilds or reorganizations within a database maintenance plan. And I say this is for 2000 or for versions of SQL Server under or less than 2016. With SQL Server 2016, you can now schedule reorganization or rebuilds based upon fragmentation levels. But SQL Server 2014 and below, you could choose to rebuild everything or reorganize everything. There wasn't a whole lot of logic outside of that. Custom scripts within a SQL agent job, such as Ola Hallegren's index optimize script, and there's third-party tools out there. Now, I like some of the third-party tools because they also include like charts and graphs and different things. And if you work for an organization where you have to produce TPS reports, you're saying how busy you are and what your team is doing, having this kind of data to say, oh, we had to rebuild X numbers of indexes and we had to reorganize X number of indexes, on a within the past 7 days. That data is also logged within Ola Hallegren's index optimize, but the third-party tools, can have charts and graphs and may make it easier because you don't have to query the data directly, but we're data folks, we can query. So by having that data logged, you can report how busy you are, right? Well, having that data also means that you can look to see if you're rebuilding indexes once fragmentation gets over a certain percent, and you're reorganizing where it's between, say, 5% and 30%. And you're doing this on a weekly basis, and you're consistently seeing that you're having to rebuild certain indexes every single week because they become over a certain level of threshold of fragmentation. You may want to look at that index and see, why is it a hotspot? What's going on? Do we have the right fill factor? Do we have the right clustered key column? Why is it becoming so fragmented? And it could just be that it's a dump table where the data is truncated and new data coming in, and it's just a trash table to begin with. And fragmentation really doesn't matter based on the nature of the data. Or it could be that it's a very, very important data table or index, and truly do need to look at fill factors and the proper clustered key columns and make sure that that the table is properly optimized. So good data that you can noodle on and try to learn more about your systems. That's really getting into some of the fine tuning. But you can also roll your own charts and graphs, because we know that C-level executives love charts and graphs. So you can do your pie charts, bubble charts, line graphs with that data set on numbers of databases per tables and fragmentations, and make it look like you're extremely busy. But fragmentation, yes, it's still a thing. There's some folks there that have thrown some data out saying if you have solid state hard drives, you don't need to worry about fragmentation. Well, in those cases, the disks are so fast that yes, it kind of masks things, but I've yet to come across a client that has more RAM than storage, where say they have a terabyte of RAM and a 500 gig database and a terabyte SSD to where the whole database can be in memory. In those cases, okay, you've masked problems. What I tend to come across is a database that, or an instance that may have 128 gig of RAM, a terabyte database, and a little more than a terabyte worth of storage, where even if it's still an SSD, multi-terabyte SSD with a terabyte database and 128 gig of RAM, wasted buffer pool space is still wasted buffer pool space, and that's a prime commodity. So I'm still going to recommend that you take care of fragmentation, and my colleague Jonathan Cahias has a SQL performance article on that exact situation. All right, other defaults. So I had mentioned the statistics. We do have the auto update statistics that's in place that attempts to help. There is no auto fragmentation handler, and other defaults. The default for memory usage is kind of far out there. Your max server memory value is set to a very large number that equals 2 petabytes. It's hard to find a large client that has a petabyte of storage, much less a petabyte of RAM, or even come close to 2 petabytes of RAM. So that's a very large number, and your minimum memory set to 0. So what this does is set SQL Server up to starve the operating system, and the operating system to starve SQL Server. So SQL Server will just continue to grab as much memory as possible, and it can starve the OS. The OS needs to do some work. It has to ask for memory. SQL Server has to back off some, free it up. The OS will complete its task. It's a nice neighbor. It releases that memory. SQL Server will grab it back up, and it creates this perpetual bad situation. In SQL Server 2008 R2 and below, your max memory applied to the buffer pool only. With 2012 and up, it's still set to 2 petabytes for the max memory, 0 for minimum. There was a complete memory manager redesign, so now the max memory applies to all memory manager allocations. Now there are some folks that say with 2012 and up, you can leave the defaults and let SQL Server dynamically manage memory. I've asked a few of my friends up at Microsoft that work on various teams, and the question on 2012 and above, do you still set max server memory? And they said, absolutely. And I said, well, why? If we can consider letting SQL Server dynamically manage the memory. And they're like, well, just in case. So I do the same thing. So just in case, on all instances, I still set max server memory, and I will kind of fine tune it over time. And Jonathan Cahias has a blog post out there, how much memory does SQL Server need? And this is not the definitive, absolutely, this is the value, never change it. It's a fantastic starting point. So he has an algorithm based upon the amount of memory, how much to give to SQL Server, how much to give to the OS, and then encourages you to monitor the M bytes available perfmon counter to see how much memory is still available. And over time, you can increase that up or back off max server memory to make sure that operating system still has what it needs, but that SQL Server can use as much as possible without killing or starving the OS. All right, other default settings. So max degree of parallelism. Max degree of parallelism by default is set to 0. That means an unlimited number of CPUs could be used to execute the parallel region of a query. And that unlimited is really not unlimited. It's up to 64 unless you put in a trace flag that allows it to use more. But I don't find too many customers with more than 64 logical processors to worry about. So still 64 is a very large number. So the recommendation here is if you have more than 8 CPUs, start with 8 and modify from there. If you have 8 or fewer, you can use 0 up to n being the number of logical processors or logical cores. So a common question comes up. All right, on virtual machines, do you still need to set this? Well, are there more than 8 vCPUs? If there are, I tend to still set it, and I do try to look at how those CPUs are allocated to the virtual machine to make a more wise decision. But most VMs that I work with have anywhere from 2, 4, 6, 8 vCPUs, and in that case, the 0 to n applies. So if I have 4 vCPUs, do I set it to 4 or do I leave it to 0? Well, 4 still fits within the recommendation, but 0 by default equals 4. So on VMs with low numbers of vCPUs, you can leave it to the default, or you can set it if you're concerned with your client or someone increasing the number of virtual cores on that host, or excuse me, on that guest. Physical machines, yes, this is where I dig in. There's a Microsoft support article that does, I believe that article does get into some of the NUMA configurations. So one of the things I like to try to do is if I have a machine that has 12 CPUs, but they're 6-core processors, I'll set maxed up to 6 to try to keep things within the NUMA nodes. Another is your cost threshold for parallelism. And to me, this one is quite important because this determines the query subtree cost is your cost threshold for parallelism. So the arbitrary value of how expensive that query is. So the current default is 5. 5 used to mean 5 seconds back in like the SQL Server 7.0 2000 days. Now it's just an arbitrary value. It's a unit of measurement, and 5 is way too low. So the recommendation now is you need to increase the value of the cost threshold for parallelism to a higher number. And we at SQL Skills tend to recommend anywhere from 25 to 50 based upon your environment. Again, Kahayas, I guess he could not sleep one evening and just went through and wrote this very awesome article about how to go through and dig through the plan cache to find which queries are executing parallel and what their cost threshold values are. And you can take that data and see, one is there a big grouping, there's this huge grouping of queries that are executing, their cost threshold is 35, and I start looking at those queries, and I might be able to optimize a few of them, so I do, but the other ones, not so much. And when I pass a maxed up hint of 1, I see that the query is just much more efficient. Well, I now want to increase my cost threshold to a higher value and make it 40. So Jonathan kind of steps you through that whole process of, all right, yes, increase it to a higher number, kind of monitor the system, and then to fine tune, you want to dig through the plan cache, look at those queries and see, is that truly the best value? And I will tell you, I know of other consultants that work for large companies, and I've seen as high as 250 as the base cost threshold for parallelism. So it really all depends on your environment, your workload. A thing to mention with the max degree of parallelism, there are applications out there that will require you to set max stop equals 1, things like SharePoint. In those cases, follow your vendor's recommendation, and if you're seeing really weird behavior, reach out to somebody and see if we can't help. But maxed up for the most part, unless it's a vendor recommendation, you want to set it to something other than 0 on those large physical machines. All right, another fun one, Temp DB. This one's always fun to come across. And with Temp DB, some unique characteristics. It's recreated at startups. Every time SQL Server Service is restarted, Temp DB is recreated. You only have 1 Temp DB per instance. It is modeled after the model database, meaning if you have it resized Temp DB, when it's restarted, it's a meg or so, auto grow for the data file by 1 meg, your file by 10%. That is for SQL Server 2014 and below. 2016 changed things. We'll talk about that in a moment. A good trivia question. It's also a good interview question. Get your candidate to start talking about Temp DB and how important it is, what uses Temp DB, and then ask how often should Temp DB be backed up? Well, you really can't. Of course, people argue, well, I can take a snapshot of it, I can do things. Well, try to run the backup database Temp DB to disk statement, and it will blow up. So that's just a neat Jeopardy question. So considerations with Temp DB, with 8 cores or less, you want to create equal size data files per the number of cores. There's some older blog posts out there that says 1 file per core, and there was no restriction. You would find people creating 64 Temp DB data files, 120 Temp DB data files. Heard of legit cases where you need that large of a number for contention, but for the most part, we don't. So if you have 8 cores or less, equal size data files per the number of cores. That's because Temp DB uses the proportional fill method. So equal size so that they all get abused equally. With 8 or more cores, you want to start with 8 equal size data files and increase by 4 files based upon contention. There is a support article here for contention. Why this is kind of important is your PFS page is page 1, your GAM page 2, SGAM page 3. PFS repeats every 64 meg within the file, but your GAM and SGAM repeat every 4 gigabytes. So until that data file grows above 4 gig, you have a single GAM and SGAM page and very few PFS pages. So you'll see contention on those 3. By creating multiple files, so let's say we have a 4 vCPU machine, we have 4 Temp DB data files. Let's say they're only 60 or 50 meg in size. Well, that would give us 4 PFS, 4 GAM, and 4 SGAM pages. So that helps with contention on those 3 pages. Other things for Temp DB, you want to enable trace flag 1118 always on 2016 and above. That trace flag behavior is on by default, and that says when an extent is created, create all 8 pages at the same time. So for 2014 and below, you want to make sure 1118 is on. There's another trace flag 1117 that says when a data file has to grow all files at the same time. That's an instance level setting. So we don't recommend that you always enable that one, because you could have other databases that have multiple files within a file group. They'll take on that behavior too. So unless you're in that level of behavior that Temp DB needs it, we say don't turn it on, because it can have other impacts to the instance. For 2016 and above, that behavior for trace flag 1117 is on for Temp DB by default, which is great because it's just on for Temp DB. Other considerations: if you have a really busy Temp DB, you're generating lots of I/O, you could consider placing the data files on separate disk with faster I/O if needed. Temp DB is not always the most I/O intensive database. So if you have limited SSD storage, it may be that Temp DB is not the best to go on that. Maybe you need another data file, log file, something else to utilize that faster I/O. Also consider enabling instant file initialization, so that when Temp DB creates and you have all those data files, that they zero out immediately, and you don't have to wait for zero initialization. SQL Server 2016 prompts you so you can check the box to enable instant file initialization during installation, which is fantastic. Otherwise, it's a security policy for the perform volume maintenance task. You want to add the SQL Server service account there. And so I mentioned for the considerations. So when you install SQL Server 2016 and above, when you get to installing the engine portion to Temp DB, it will prompt you to create multiple files based upon the number of logical processors that SQL Server sees. And the auto growth is no longer 1 megabyte. I believe it now is still 64 meg for the log and data files, which 64 megabytes is better than 1 megabyte, but depending on your environment, 64 megs may still be way small, and you want to increase that to a much larger number. I've seen some be gigabytes in size. So again, it all depends on your workload, your environment, and so forth. All right, SQL Server agent alerts. I mentioned in the overview slide about free SQL Server monitoring, and this is kind of it. I mean, it is limited, so you're not going to get a ton of bells and whistles, but it is very important that if you're not running a third-party tool that's monitoring for these fatal errors for you, enable SQL Server agent alerts. All you need is database mail. You should already have mail enabled so that you're getting notifications if your check DB job, your backup jobs, your index optimize, all those jobs fail. You want to know about those without having to go and manually check on a daily basis. So mail should already be enabled, so then you can create a mail operator to send the alerts to. So I recommend a distribution group, not just yourself. You may take a holiday. Who is someone else that can get notified of these fatal errors and be able to help you out? So maybe the DBA team, the IT team, someone else. So your agent alerts, errors 19 through 25 are all fatal alerts. This means something very, very bad happened, and whatever transaction was in process at that time that encountered the error is rolled back. Error 825 is related to an IO operation retry. It means that SQL Server tried to write to disk. It couldn't. It tried again, and at some interval of the retry, it was successful. So, hey, great, the data still got written to disk, but it should always get written to disk. It shouldn't have to retry. So this can indicate that there's a IO subsystem problem on the rise. So if that occurs, immediately notify your storage admin to say, this bad thing happened, figure out what happened. So you can create your agent alerts using the GUI or a T-SQL script. If you use the GUI and you go through all the checkboxes, right before you say OK to create, choose the script to new window, copy and save that script, and now that's part of your SQL Server build. So you can apply that to all your other servers and any new servers that you create. So again, database mail happen. There's a document process, step-by-step. All you got to do is change the email operator at this bit.ly link, and it will create your errors 19 through 25, your 825. Glenn Berry also has a blog post out there on doing this exact same thing as well. And a lot of the community have kind of added to the list of, oh, here's another error that you should add for different versions, what the different errors mean. The bit.ly link on the screen also includes, or it's a performance article, and the article just after that one from me is, what are errors 19 through 25? What do they mean, and what do you do to fix them? And unfortunately, just about every one of them is you're restoring from backup. So it's some fatal corruption level that's just really bad news. All right, and we have another fun one is power savings. So power savings, it's a good thing. I mean, we need to be environmentally friendly, right? I mean, we don't need to just continue to burn power. And many of us, we go on flights and we take trips and we have laptops that we would like for the batteries to last forever, our phones. I think one of the biggest things to have helped the generation coming up, like my kids, on being more conservation of power was Pokemon Go. So the low power mode in that application or that game, so that their battery wouldn't die in 2 hours of them playing Pokemon. All right, so our servers, our laptops, all come with balance power enabled. So that means that when it comes unplugged, the screen dims, the CPU will run at a slower speed, the hard drive will go into idle if it's not being used after so many minutes, and that helps save the batteries, and that's fantastic. The problem in data centers is if your SQL Server has balance power enabled, so either power management within the BIOS, balance power within the operating system, it can dumb down your CPUs. So you may have a 2.8 gigahertz processor, and it will idle it down to, say, 800 megahertz. So you're going from a 2018 technology processor speed to something in the late 90s, early 2000s. And those processors cost thousands or thousands of dollars depending on the processor that you select. So now we're going to take that $10,000 processor and have it running like a $200 chip. For some applications, that behavior is okay, because as soon as a workload comes in, CPU ramps up, and it does its thing, and okay. For SQL Server, it's not conducive to that type of behavior. So it makes bad things happen. And I've had clients reach out, hey, we upgraded hardware. We literally just demotioned from one machine over to another, or we did some type of, it was boot from SAN, we just replaced the blade with a faster one, and things are just horrible. Now CPU spiked to 100%, can you help? And we take a look and it's like, oh, well, you need to disable power savings in the BIOS. They do that, and then boom, they're back to 20% CPU, or they upgraded, it's a new machine, OS, everything, and balance power is enabled within the operating system, and they just flip the switch and immediately things go back to normal. So it's a real problem. It's becoming less and less of a problem because now VMware and other vendors are noticing this, your Cisco UCS, all of those, and there's documentation on, yes, for high OLTP workloads like SQL Server, you want to make sure that balance power is turned off, and VM admins are turning off the power management in BIOS and things. So it's becoming less, but we still see it quite often. There is a free tool, CPU-Z. You can get it from cpuid.com. Download just the executable, run it on your machine, and it will show you what the current clock speed is in use. So if you see that the processor is a 2.8 gigahertz and you're running at 900 megahertz, you have a problem. And then power savings can also do other things like turning network interface cards off, which is quite problematic if your SQL Server just kind of disconnects from the network. So food for thought, things to think about, common things that I see out there. So my kind of tagline is, SQL Server is great, but a next finish install is not good. For many people, they can install SQL Server, create a database, start pushing data into it, and it works fantastically well for a long period of time, but they're going to hit some tipping point where performance just degrades. And out of going through and doing a lot of these common fixes, you can get quite a bit of life out of that instance again without having to do really hardcore tuning. So you want to make sure, first and foremost, that you have proper backups to meet your recovery needs, that you're running regular consistency checks, so when corruption occurs, you can be notified of it as quickly as possible and take action. Performing your log cleanups for MSDB and your SQL Server log. You want to make sure that statistics are being updated so that the query optimizer has the best chance possible of generating the the good enough plan. Proper index maintenance. Memory settings. You want to make sure you have a max server memory value so SQL Server doesn't starve the OS. Configure max stop and cost threshold for parallelism for your instance based upon your workload and core counts. Configure Temp DB for your instance. Take advantage of the free SQL Server agent alerts. And lastly, turn off any power savings. Again, it's fantastic for your tablets and your laptops, but not your data center server. So I want to thank you all for coming out, giving of your lunch hour to learn more about SQL Server. And if you have any questions, I know there were may have been some asked in the window. We can try to get to some of those. If not, I'll get the list sent to me and I'll email a response out to everyone. You can also reach out to me directly, Twitter @tradney, tim@sqlskills.com. And thank you all.
Thanks, Tim. Yeah, I got a couple of questions that will probably be good for you. Sorry, I meant to get them while you were talking about the topic. Got one here from asking if does setting the power setting on a VM make any difference, since it's different than a on-premise server?
Yeah, so if more there on the physical host. So if the host, because once you're in the hypervisor, it can be doing some really gnarly things where it may be idling down the CPU and you're not actually seeing that. So for all of my customers on VMware Hyper-V, I strongly encourage them to talk to their virtualization engineers and disable any power savings in the BIOS. That one is a little bit harder to pinpoint and troubleshoot, but there are things that you can derive from within vSphere. But if they need more on that, they can email me directly and I can follow up with more detail.
Cool. We have a question here they might enjoy. What is the best way to shrink Temp DB?
Yes. Restart the instance. No. There actually is a couple of legitimate reasons where you may need to shrink Temp DB. I don't know if this person was being kind of a joke or for real, but you can run a shrink command if Temp DB has grown. In cases where Temp DB grew and it's on the same disk as the user database files, and one of those is at the point to have to auto grow. Previously, there was documentation, never shrink Temp DB. It could cause corruption. That is not true for modern versions of SQL Server. I think it's actually 2005 and up. It's okay to shrink. Paul did a blog post a while back. You can Google that or Bing. But the regular shrink command, but many times it won't actually shrink because a portion of it that is toward the end of the file that is in use, and you just can't. But you can clear the buffers and proc cache and things and try to shrink in an emergency. But most of the time, you just wait till maintenance and restart the instance and resize it properly and find out whoever's causing the bad behavior to cause it to grow out of control and try to shrink them.
Okay, we have a question back at the very start. Someone just wants to know, for clarification, does CheckDB cover all other checks like allocation, catalog, file group?
Yeah, so it does the allocation. the benefits of the separate commands is if you don't want to run the full CheckDB against the entire database, you can do individual file groups if you have multiple file groups. If you know the problems just within an allocation map, then you can run just check alloc instead of having to run full CheckDB. So that's the benefits of the more granular, but yeah, full CheckDB does the entire gamut, everything.
Okay. Someone wanted to know if in SQL 2016, is the trace flag 2371 on by default?
2371. I'm not sure. I'll have to follow up on that one. I know there's a number of trace flags that are the behavior's on by default in 2016. I would have to confirm.
Yeah, that's no problem. Like, okay, this is kind of interesting enough. So somebody's asking, by default, auto update statistics are turned on. Are you suggesting that we, instead of leaving that SQL Server to update statistics based on its 20% plus 500 rows changed, we need to update the statistics based on when the plan isn't good? I kind of think this is a case of there's a slight mix-up between the ascending key problem and just the update statistics, but it'd be nice to get your opinion on it.
Yeah, so the auto update statistics value, there is a trace flag you can turn on to decrease that. We always recommend leave auto update statistics on as kind of a safety net, but you need to be updating statistics manually yourself much more frequently. So it's not a, hey, wait until I have a problem, update statistics. You want to, on a regular basis, whether that be daily or weekly, to run a update statistics process. So with my clients, when I implement Ola Hallegren's solution, if they have a maintenance window where we can run that nightly, then there's fragmentation's being taken care of, and any tables that had or any data that had row modifications, statistics will be updated for that as well. I'm hoping in a future release of SQL Server, we will see the ability to update statistics based upon percentage of data change, so that we can have it more granular. So, okay, once 3%, 5% of the data has had modifications, update statistics, but not on a billion row table. If there's been one record change, that bit has been flipped, and now update statistics would want to run with Ola's process or any other process that's doing a where there's been row modification. So whether one bit or one row or a million rows, it sees no difference. So we're hoping that we'll see something where it can be much more robust, where it's percentage based. But no, I do not recommend waiting until you have problems or you're seeing erratic behavior to update stats. I mean, there's no real justification there. Update them more frequently as data is being changed. You want to update statistics.
Yeah, that's fair enough. I suppose I'm going off that. There is another question here on, so let me just find it again. There's quite a few coming in. Yeah, going off that, there is a question on what should the ideal percentage be to decide whether to index reorganize or index rebuild? So going from statistics to indexes.
Okay, so this has been there's some data that's been put out, and I think Paul Randall was one of the ones that was asked what are the values, and it's based on his experience between, if it's over 10%, less than 3%, reorganize, over 30%, rebuild, and that's pretty well become the industry standard. I've seen a lot of third-party tools and custom scripts out there that say 5 to 30, reorganize, over 30, rebuild. And the consistent thing has been over 30%. And I think that's been tested and validated, and people trying to see, is that still really the best value? And for the most part, I mean, it's checked out. Once you get over 30%, just the overall cost for the reorganization and time versus just rebuilding, makes sense to rebuild. A difference comes in depending on your version of SQL Server. A rebuild could be an online operation or an offline operation. If you're Enterprise Edition, it's an online operation. Well, if I'm Standard Edition, I'm 24/7. I really can't take the hit to do rebuilds and have indexes go offline. So I'm going to reorg always, and I'm going to generate a ton of transaction log, but that's the best thing for my system to keep, be the less invasive. But yeah, I mean, 5 to 30 is the reorganization threshold, and over 30% is the rebuild.
Perfect. Yeah, perfect. Well, we still have like double digits of questions, so do you mind if I ask you like 1 or 2 more, and then we'll just send the questions on to you to answer yourself? So we do have one asking, how frequently would you recommend running a full check DB?
I recommend no longer than once a week. So full check DB, once a week. Reason being is, most of the people I come across, they're keeping backup files for 2 weeks, 14 days. So think about the logic through there. If we're running CheckDB on Saturdays, we're running full backups on Sunday. So I run CheckDB on Saturday, I have a backup on Sunday. I'm not running CheckDB again until the following Saturday. Well, that Saturday it runs, it has problems, detected corruption. I'm on vacation that week. So I'm not seeing the CheckDB failed. I come in from vacation on Monday, I have a flood of emails, a week's worth that I'm going through. It may be the following Tuesday, Wednesday before I notice, oh my gosh, we had corruption on the database. Well, from the time that it ran, the retention been a full week before corruption determined, I'm on vacation for a week, come back. I try to go back to the Sunday backup from 2 weeks ago, and what do you know, the corruption's there, and I don't have a backup further past it. So that's kind of the risk here, is you want to make sure that your backup retention allows you to be able to go back prior to the corruption in just about all circumstances. So if you're the lonely DBA, you need more than 2 weeks of backup retention, at least for when you're going to be out of the office for an extended period of time. So once a week minimum. I have some clients, like I said, they're small systems. They have the IO. The job runs on a daily basis, but at the minimum, I like to see once a week. Folks that are doing it once a month, I mean, that's super risky, because then your backup retention. I've worked with too many clients where they don't have a backup, they have corruption, and we can't do anything for them, and that's a very hard news to deliver to a customer.
Okay, I think I'll leave it to the final one, just because I want people to go and enjoy what lunch break they have left. But this person does ask that sometimes they will rebuild indexes, and it doesn't resolve fragmentation for a large table, and they just want to know what could the possible reasons be.
I would need to know more about the tables, but I mean, certain data types could be interfering. That would be the only thing that's really coming to mind, would be certain data types.
Yep, that's no problem. Like you can't really make a informed or a misinformed opinion when you don't have the information, so that's fair enough. Okay, and that I think is around it. We do have a lot more questions, and they're still coming in, but we're also getting a lot of the thank yous, and when I get, let's say, more than 20 of them, I realize, okay, I think people are leaving. So thanks a lot for that, Tim. No, I'm not sure if Steve is on the line. He normally takes over, but if not, I will just get the slides up here. But I do want to say thank you so much for coming on and giving the presentation, sharing your knowledge. It's really great to get that, especially from someone as knowledgeable as yourself.
All right, well, thank you so much. And again, anyone that wants to email directly with questions, they can feel free.
I am online. It was great, and I probably wouldn't be able to show my screen anyway. I'll forget it or something. So anyway, thank you.
All right. Well, thank you all for having me.